3-phase induction motor. An induction motor consists of two part. One is stator and other is rotor. Stator it is a stationary member. Stationary member of induction motor which is 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 outer body of motor. Rotor it is rotary part. It is rotary part in the motor. It is rotary part in the motor. Rotary part in the motor and 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 two type two type two type of rotor construction 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 in three-phase induction motor. One is squirrel type squirrel cage rotor, and second is wound rotor. Wound rotor type. type. Here here the stator stamping construction. Here the stator stamping construction are shown. So this is the outer portion. Then slot portion. This is the slot. This is the slot. This is slot. Slot. This is the slot portion. This is teeth, tooth. This is the slot. Slot, slot. The stator is stationary part of an induction motor. Stator, stamping, hysteresis and eddy current loss occur in the stator. Hysteresis and eddy current loss occur in stator because of changing flux associated with it. Eddy current loss is directly proportional to square of thickness. Eddy current loss is directly proportional to the square of the thickness thickness. As such, stator is laminated and the thickness of lamination is kept minimum possible to reduce the eddy current loss. The eddy current loss is directly proportional to square of the thickness. As such, stator is laminated and the thickness of lamination is kept minimum possible to reduce the eddy current losses occurring in the stator. Hence, stator is cylindrical structure and is built up of dynamo grade sheet steel lamination of 0.35 or 0.5 mm thickness. Dynamo grade sheet steel lamination of 0.35 or 0.5 mm thickness because neutralize the neutralize or to reduce eddy current loss occurring in stator. In small machine, the thickness of lamination may be slightly higher. Slightly higher. These laminations are insulated from the each other by means of either varnish coating or oxide coating. In a small machine, the thickness of lamination may be taken slightly higher. These laminations are insulated from each other by means of either varnish coating or oxide coating. The slots are punched out on the inner periphery of the stator lamination. These laminations are assembled in a steel yoke. These laminations are assembled in a steel yoke. The laminations are in the form of complete ring for small and medium size motor as shown as per figure. The stator core is made up of segmental lamination for large size motor. The stator core is made up of segmental lamination for large size motor. Radial ventilation duct are provided along the length of the stator core. In order to improve the cooling. For every 6 to 6 centimeter length, a ventilation duct is provided by using spacer placed between lamination. Stator consists of 3-phase winding placed in the insulated stator slot. Insulated stator slot. These windings are connected either in स्टार और डेल्टा. इनका जो वाइंडिंग है स्टार या डेल्टा में कनेक्शन होता है. बोलता है कि फॉर एवरी 6 or 8 centimeter length, a ventilation duct is provided by using spacer placed between lamination. Stator consists of these 3-phase winding placed in the insulated stator slot. These windings are connected either in star or in delta. Second, rotor. Rotor is also built up of dynamo grade sheet steel lamination. The frequency of rotor flux is very low. As a result, thicker lamination can be used without excessive iron loss. The number of ventilating duct provided in rotor core is equal to the provided in the stator core. The number of ventilating duct provided in rotor core is equal to the provided in the stator core. Slots are punched out in the rotor lamination to accommodate the rotor winding or rotor bar. For small size slot are punched out in the rotor laminated. For small size motor, punch rotor lamination are stacked and fitted directly on the shaft. For large size machines, lamination are fitted onto the spider web arrangement on the shaft. Suitable bearing should be provided. Suitable bearing should be provided at both end of rotor, and rotor must be properly balanced to avoid the danger of the rotor striking the stator. The end of rotor, the rotor slot are generally skewed by a certain angle with the shaft so as the reduced magnetic noise. The rotor slot are generally skewed by a certain angle with shaft so as the reduced magnetic noise to produce more uniform torque and to prevent possible magnetic locking of rotor with the stator. Two type of rotor construction is generally used for three-phase induction motor. One is squirrel cage motor or second is wound rotor. In squirrel cage rotor, squirrel cage rotor, rotor, squirrel cage rotor, rotor. This is the diagram. This is the diagram. This is the figure of rotor. 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 This is the general view of squirrel cage rotor. Squirrel cage rotor. A squirrel cage rotor consists of copper bar placed in the rotor slot. Rotor bar are short circuited at each end by solid end ring made of copper, brass or aluminum. As per figure, the general view of squirrel cage motor rotor of three-phase induction motor. The induction motor with squirrel cage rotor has excellent running performance. However, its starting torque is low. As such, plain squirrel cage induction motor cannot be used, whereas high starting torque is required. The induction motor with squirrel cage rotor has excellent running performance. However, its starting torque is low. As such, plain squirrel cage induction motor cannot be used, where a high starting torque is required. However, starting torque is required. Torque of squirrel cage induction motor can be increased by employing either a double cage rotor or deep bar rotor. Medium starting torque requirement can be met with such type of construction. Double cage rotor and deep bar rotor has been dealt with a detail in articles such and such. The squirrel cage motor consists of copper bar placed in rotor slot. Rotor bar are short circuited at each end by solid end ring made of copper, brass or aluminum. General view of squirrel cage rotor of three-phase induction motor. The induction motor with squirrel cage rotor has excellent running performance. However, it is starting torque is low. As such, plain squirrel cage induction motor cannot be used. Where a high starting torque is required, however, starting torque of the squirrel cage induction motor can be increased by employing either a double cage rotor or deep bar rotor. Medium starting torque requirement can be met with such type of construction. Double cage rotor and deep bar rotor have been dealt with in the detail. So induction motor induction motor consists of two parts. One is stationary member known as stator and other is rotating member known as rotor. Induction motor differ from DC machine is following. Air gap is comparatively much smaller. Absent commutator, practically a constant speed motor, laminated stator. Induction motor, three-phase induction motor are less maintenance and are cheaper compared to other type of motor of equal kilowatt and speed rating. As such, these motors are widely used for most of industrial applications such as centrifugal pump, conveyors, compressor, crushers, punch pressure, etc. In 1891, by Tesla, introduced the induction motor. The construction of motor was improved by using distributed stator winding and cage type rotor. Higher efficiency and better power factor and high start torquing. The power factor and efficiency of these motors are quite high. So medium rating of motor may have an efficiency as high 90% and power factor 0.89. So some introduction are given for induction motor. Induction motor. थैंक यू। अगर आपको वीडियो पसंद हुआ तो लाइक कीजिए, अगर पसंद नहीं है तो डिसलाइक कीजिए और कमेंट में शो कीजिए कि थैंक यू।